Hey guys, so welcome back to your next class of Catalyst Concepts. In the previous session, we started a new chapter, and that is Metallurgy. We looked at what are the different terms that we can use in terms of metals. Like one we talked about is minerals. We learned about what a mineral is, and we learned about some special types of minerals whom we call as ores, right? So ores are basically the minerals that can be used to extract the metal from them, and it is these ores that we'll be talking about going forward in this chapter. All right, so now we know that we need to take this ore in order to get metal out of it, but how do we do that? Okay, so how is it exactly done that a lump of rock or whatever is obtained from the earth, how do we change that into like a purified form of metal that we use in our daily lives? So for any ore that is there, there is a certain process that is involved. For each one, there'll be different methods within the same process. Okay, so uh, there is a basically three-stage process that we call it. Okay, so there are three steps to this. The first step is called, okay, so I'll just put the heading ore over here. Right, so the first thing that we do with this ore is, the first stage is called concentration of ore. Okay, so once you have this whole ore with you, the raw material, you do the first step, which is called as concentration of ore. After finishing this stage, you go to the second one called extraction of crude metal from ore. Okay, so extraction of crude metal, and after this stage we go to purification of crude metal. Okay, so if we follow this three step, like I said, within these, like within concentration, there's different methods that can be used for different types of minerals or ores that we use going forward. Okay, so today we'll be talking only about one of these steps, and that is nothing but concentration of the ore. Okay, we'll go with the first step for today. Okay. What exactly does this concentration of ore stage have? Okay, in concentration of ore, what you're trying to do is remove impurities that are not needed. Okay, so basically remove impurities that are of a physical kind. Meaning, say for example, you get the ore out of the land, right? When you get it out of the land, there'll be a lot of sand, there'll be like some stones, there'll be some unrelated matter that is present inside of this ore. Okay, so you don't get like a pure rock out of it. It'll be a lot of impurity with it. Okay, so when you're physically trying to separate these, that is called as remove, that is the concentration. Okay, so basically I'm trying to remove anything that is not related to our main ore. Okay, for example, if I have aluminum ore, anything in that bunch that is not at all aluminum or not actually the ore, I'm going to try to remove that. That is concentration of ore. Okay, now since it's a physical process, there can be different types of methods involved in it, again depending on their physical properties. Okay, we can use certain physical properties to separate them. Okay, there are some methods that are actually quite easy and quite simple logical. Okay, let's start with those. Okay, the first one is simply hand picking. What is the meaning of hand picking? Right, hand pick, as simple as that. So what happens in hand picking is, if you have this ore, right, and it looks very different from the impurities, you can simply pick it out with the hand and reject the rest. That is all hand picking is about. Okay, so hand picking will depend on your visible properties of that ore. Okay, say it has a different color, if it has a different size, a different shape, then you can use these properties by side. You can separate the ore from the non-ore, right? It's a very simple process. But what if it is not very distinct? What if, say, your ore looks more or less similar to your impurities? Then what do you do? Okay. So generally what happens is, when you come for this stage, you sometimes will be beating this ore into powder. Okay, you'll be grinding it into dust or smaller particles, or breaking it down. Okay, if I have done that and I can't really tell what is what, there is one more method of doing it. Okay, this is called as washing. Not the same washing that we do for our clothes, it's a different type of washing. Okay, so what washing can help us with is, generally if you have sand or just like some light sediments that are not very heavy, but your ore is, say, for a heavy metal like iron, then there will be a difference in the weights of these objects. So the impurity is going to be light, or let's say less dense, and the ore is going to be more dense. So what washing involves is, you take this pulverized ore, what we call as pulverized ore, nothing but broken into powder. You kind of put it on a slope, okay, on a mild slope, not a very steep slope, maybe like a mild slope like this. Okay, this mild slope will have like small slats in between, and you put the ore on this. You kind of just put the ore on top with the impurities. Then you take a gentle flow of water and you just let it flow on top of this. Okay, a very gentle, not a very, wild or hard flow. Once you do that, what will happen is, all the light impurities, they just kind of flow off with the water. Okay, they'll just like get carried off and then flow off. Since it's a slope, the water will carry, all the light impurities get carried on, all the heavy ores that are actually needed will get settled down on the slope. So the impurities will go and the ore will settle over here. Okay, another simple process. There are two other processes that will use different properties for this. Okay, one of them is called magnetic separation. Okay, I think it's in the name. What if your ore is magnetic? Like for example, iron is a very magnetic material. What if you have a magnetic material? You can use that magnetic property to separate it very easily. Okay, so for this we have a small diagram to depict this one. Okay, so what they do with this magnetic ore is, once you've beaten it into pulp or whatever your powder is, you pour it onto a belt. Okay, so this is a conveyor belt. It just keeps rotating like that. Okay, the ore is falling from this funnel. This belt is run by two wheels, if you can see, right? These green colored wheels. One of the wheels, it says it has a magnetic property. Basically, it's a magnet. Okay, and the second wheel will not be a magnetic wheel. Now, what will happen because of this is, anything in this powder that is not magnetic, be it your sand, soil, whatever it is, it's going to just fall right off the belt like this. But if it's actually magnetic, like your iron, the physical particle ions that you are, trying to extract from this ore, they'll stay stuck to this wheel a little bit longer, like on the belt. Okay, since the belt is in between, they won't get stuck on the wheel. But as the wheel rolls and it goes, once they're out of touch with the wheel, then they'll start to fall. Okay, so they fall a little separately. So very simple method to separate your magnetic from your non-magnetic substances in your ore. The non-magnetic is basically you just throw it away and you use the magnetic substance. That will be your final product from this stage. Okay. Finally, so I'll just write magnetic nature over here. The diagram is also in your textbooks. You can just like take a look at that. Finally, we have something called a froth flotation process. Okay, by far the more bigger process in this is froth flotation. Okay, now this is specifically used for something called as sulfide ores. Okay, for sulfide ores. Now, a very unique property of this sulfide ore is that any sulfide will not get wet by water. Okay, when you put it in water, it doesn't actually let water stick to its surface. Okay, so we call it non-wetting property. So everything else generally like sand, soil, whatever it is, it'll get wet with water, but this won't. If we can use this property to our advantage, that is with froth flotation process will come in. For that we have this diagram. Okay, so what they do basically, they'll add all of your ore into water. Okay, in a big tank of water. In that tank of water, they'll also add something called pine oil. Okay, pine oil is nothing but a sort of oil that can get frothed very easily. You know what froth is, no jhag, what we say, right? You can't directly use soap, they use pine oil. It's an industrial process. So, okay, so once you have this mixture of pine oil, water, and your or whatever ore particles that you have, you see this big tube over here coming inside the water. They push air through it. Okay, compressed air at a high pressure. By compressed, it means at a high pressure. Once it gets out in the water, it will create that froth because of the force that it's coming out with. Okay, you do know you need air for frothing. Once that happens, what happens is any particles in this ore that is sulfide, since it's something that doesn't get wet, it gets caught up in all of the bubbles in the froth that comes out. Anything else will just get, wet with the water and stay at the bottom of the tank. Okay, everything that is sulfide goes up with the froth and stays in the froth. Once you have this process complete, what you can do, you remove the froth, okay, and you just wash it off, and you will be remaining with those particles, that is your ore. Okay, and whatever remains at the bottom, it's also called as ganj. Okay, GANGV, ganj. Okay, it's basically just the waste material, or it's also called slag sometimes. Okay, so this is the froth flotation process specifically used for sulfide ores.